Okay, so here we have our second question from section B. An object is vibrating in air. The vibration with displacement x and acceleration a of the object is shown below. So we have this graph, which we're going to be analyzing and using. Let's firstly look at some of the questions that we're going to need to answer, and then we can come back to this. We are going to need to look at and explain two reasons why the graph opposite indicates an object executing simple harmonic motion, and then use the data from the graph. So here we're going to state the amplitude of the vibrations and what is meant for okay, so from that we will work from that. Okay, let's just answer this question over here. Two reasons why the graph opposite indicates that an object is executing simple harmonic motion. Now you've got 4 points here. So for each one, there's two reasons here, and each one you're going to need to put an extra point, a relevant point, to make sure you get all the marks for this. So let's go back to our graph. Now, why is this executing, as it says, executing simple harmonic motion? Two reasons for that. Well, what we have in this case is that we can see, due to this being a straight line, and it's going through the origin. See, it's going through the origin. We can say that our acceleration is proportional to our displacement. Okay, it's a proportion graph. So that would be one thing. This point, making this point, straight line going through the origin, acceleration is proportional to your displacement. And because this is a negative slope, it shows that the acceleration is always in the opposite direction to the displacement. And so that's why we get our formula. A is equal to minus omega squared x. A is proportional to this minus x value. Okay. So that would be worth 4 marks. You need to put in all those points to get your 4 marks there. Now, the next part, it says there, use the data from the graph to show that the frequency of oscillation is 350 Hertz. Now, you're going to need to think of two different formulas here. Firstly, as we discussed already, that A is equal to minus omega squared x. So from this graph, what can we get? Well, we can get from this graph, because this is a proportion graph, we can get our slope, which is equal to that. So the slope of this graph is going to equal to our omega squared, and then from omega is equal to 2 pi f, we will be able to work out our frequency. Okay, so looking at that, we could use, probably the easiest to use, this is going up to 2,900, so this value is 2,900, and here we've got 0.6, so our slope, our m, is equal to minus 2,900 divided by 0.6, which is equal to our minus omega squared. So when we do that, we get our omega squared. So omega squared is equal to the square root of 2,900 divided by 0.6 is going to equal omega, and that's equal to 2 pi f. So divide this by 2 pi and we will get our frequency. And we get one thing we've got to be careful with. Careful. Very important. This is given in millimeters. So this 0.6 is times 10 to the negative 3. So I need this over here is times 10 to the negative 3 times 10 to the negative 3. Always very important to look at the units on your scales. This is fine because this is in meters per second, but we need to convert that to meters. So this will be that, and then when I get my answer, I get my frequency is about 350 hertz is the frequency. Okay, so making sure that you go to your basic definition of simple harmonic motion, which is that formula over there. Very important one to remember. Okay, now let's just go down here. So we've done that. Our amplitude obviously is very straightforward. Our amplitude is always that maximum distance, so that will be 0.6 millimeters, or 0.6 times 10 to the negative 3 meters. Okay, so the motion of the object gives rise to a longitudinal progression traveling sound waves. State what is meant by a longitudinal progressive wave. Okay, so it's a longitudinal wave. If the particles in the medium, all right, the particles that are vibrating, these particles will move parallel to the direction of the motion of the wave, or the direction of the propagation of that wave, or the energy that is being carried by that wave. So they are moving parallel to the direction. So if this is the direction of the wave, then these waves are vibrating to and fro parallel to that direction. Now we're told that the speed of the wave is 330 meters per second. Using answer and B, calculate the wavelength. Well, we know that the speed is equal to frequency times wavelength. We worked out this was equal to 350 times your wavelength. So it's equal to 330 divided by 350 is equal to wavelength, and wavelength equals about 0.94 meters. Okay, there's that question. Thank you.